Welcome to The Explainer. Now, in the world of high-stakes consulting, you are constantly forced to make huge calls with what feels like, well, not enough information. You've got a pilot program, maybe a small focus group, and that's it. So how do you get from that tiny data sample to a recommendation you can actually stand behind? Today, we're going to unpack the exact statistical tool built for this job, the t-distribution. Let's dive in.
So here's our game plan. We'll start with the challenge of small data. Then we'll introduce our solution, the t-distribution, and get the rules of engagement down. After that, we'll build out a toolkit of different t-tests, run through a real-world example, and then we'll wrap it all up with the one key takeaway you need to remember.
All right, first things first, let's frame the core problem here. We're calling it the small data challenge. And if you're an analyst or a decision maker, you know this feeling. You have to make a call, but you're working with a snapshot, just a glimpse, not the whole picture. And that's exactly where the risk of uncertainty is at its absolute highest.
So this is the fundamental question, right? Imagine you just launched a pilot program, or you tested a new feature on a tiny group of users. You got some data, sure, but not a lot. And, this is key, the real stats for your entire customer base are a total mystery. So how do you take that small snapshot and make a reliable call? Honestly, this is where a lot of projects just get stuck in the mud.
Okay, so how do we get unstuck? We can't just throw the usual statistical methods at this. Those things need big data to work properly. No, we need a specialized tool, one that's actually designed for precision when you're flying a little blind, and that tool is the t-distribution.
So what is this thing really? Well, you can think of it as a special probability map that's drawn specifically for situations with high uncertainty. It really becomes your go-to tool under two very specific conditions. First, your sample size is small. The rule of thumb is anything under 30. And second, and this is the really critical part, you have no idea what the standard deviation is for the entire population you're studying.
Now this is where it gets super interesting, especially when you compare it to the more famous z-distribution. You see, the z-distribution is awesome when you're swimming in data. It's sharp, it's confident. But the t-distribution, it's different. It's built on your sample's standard deviation, which is just an estimate. So to account for that extra uncertainty, its shape is flatter, with wider, fatter tails. That shape isn't an accident, it's a built-in safety net. It's more cautious. It basically says, hey, since we're not sure, you're going to need stronger evidence to convince me, which is exactly the kind of rigor you need when your data is sparse.
Okay, so we've got the tool, but any good tool is useless if you don't ask the right question with it. And that's where we have to get really disciplined. This brings us to the formal rules of the game, hypothesis testing. It's just a structured way to challenge an assumption with our data.
Every single statistical test starts with something called the null hypothesis. You'll see it written as H0. The easiest way to think about this is that it's the status quo. It's the boring default reality. It's the assumption that nothing happened, there's no difference, no effect. So if you're comparing two ad campaigns, the null hypothesis is that they perform exactly the same. Our whole job is to collect enough evidence to see if we can confidently say, nope, the boring reality is wrong.
So if we're going to challenge that default reality, we need a theory of our own. That's the alternative hypothesis. It's what you actually think is going on. And as you can see, your theory can point in one of three ways. A two-tailed test is basically asking, are these two things just different in any way? A left-tailed test gets specific. Is this new thing less than the old thing? And a right-tailed test asks the opposite. Is it greater? Choosing the right one is all about matching the test to the business question you're actually trying to answer.
And this is where it gets really practical. This whole structure builds out into a perfect Mies toolkit. We have three distinct types of t-tests, and each one is designed to answer a completely different kind of business question.
First up, the one-sample t-test. You pull this one out when you need to answer the question, is our group hitting the target? So for example, is our factory's bottling line really putting 16 ounces in every bottle? You've got one sample, the bottles you checked, and you're comparing their average against that one known standard.
Next in the kit is the two-sample t-test. This is your go-to for answering, are these two separate groups actually different? And that word separate is everything here. The groups are independent. This is your classic A/B test. Is landing page A getting more clicks than landing page B? Is sales region A performing better than region B? Two different groups, one comparison. And our third tool is the paired t-test. Now this one is incredibly powerful for measuring impact. It answers the question, did the thing we did actually do anything? You're measuring the same group twice, before and after some kind of intervention. Did our new training program actually improve employee test scores? You're looking at the average change for each person to see if the program really worked.
Okay, theory is one thing, but let's make this real. We're going to roll up our sleeves and walk through a quick case, step by step, to see how you go from a vague business problem to a rock-solid, data-driven answer.
Okay, here's our scenario, a classic quality control problem. And notice the key ingredients are all here. We've got a small sample, just 19 balls, that's way under 30. We have the sample's average and its standard deviation. But we do not know the standard deviation for all the millions of tennis balls that factory has ever made. It's a textbook setup for the t-distribution. Our job? Calculate a 95% confidence interval.
And what follows is just a clear mechanical process. First, we define alpha. That's our risk tolerance, the 5% chance we're willing to be wrong. Second, we find our degrees of freedom. It's just the sample size minus 1. All this does is slightly penalize us for having a small sample, which makes our result more reliable. Third, we take those two numbers, look up our t-score in a table, think of it as our uncertainty multiplier, then we use that to calculate the margin of error, and boom, we have our confidence interval.
And this right here, this is the whole point. We took one single number, our sample average of 58.2 grams, and we turned it into a statistically defensible range. We're not just guessing anymore. We can now go to the factory manager and say, with 95% confidence, that the true average weight of all balls coming off the line is somewhere in this specific range. That is an actionable insight.
Okay, we've gone through a lot. So let's boil it all down to the one single strategic takeaway you can put into practice tomorrow.
If you remember one thing from this whole explainer, let it be this. The next time you see a data set with a sample size under 30 and you don't know the population standard deviation, a little flag should pop up in your brain. That is your trigger. That's the signal that you need to be reaching for the t-distribution.
So what does this all mean for you? It means you don't have to be paralyzed waiting for big data. The t-distribution gives you a rigorous, proven way to take those small, messy, uncertain data sets and turn them into a real strategic asset. It lets you make decisions that aren't just gut feelings, but are confident, quantified, and completely defensible. So I'll just leave you with this final thought. Take a look at your own work, your own projects. Where are you sitting on some initial survey results, or feedback from a pilot program, or some early test data that maybe you've been ignoring because it felt too small to matter? Because with the right tool, that small data might just hold the key to your next big breakthrough.